Welcome to this video on risk assessment according to ISO 12100-2010. Previously, we considered that it is not only very useful but also necessary to carry out a risk assessment. Why? Mainly to protect people and the environment from damage and of course to protect the product manufacturer from punishment. For products defined as machines and brought to the European market, there is a directive which must be applied. It is called the Machinery Directive 2006/42/EC. The directive must be applied to a range of types of products. These are machinery, interchangeable equipment, safety components, lifting accessories, chains, ropes and webbings, removable mechanical transmission devices and hardly completed machinery. The directive calls on manufacturers of such as products to carry out a risk assessment. Yes, and there is also, of course, a standard which defines that risk assessment process, the ISO 12100-2010 standard. The good news is that it is an internationally valid standard. Thus, a risk assessment carried out to this standard can be applied to machines that are marketed worldwide. But what exactly is risk assessment? Let me summarize. First, we must clearly define the limits of a machine. Then we need to identify all the hazards which are present in that machine. At this stage, it is particularly important that all activities which are carried out at and with the machine are considered, as well as the different life stages, such as cleaning, maintenance, decommissioning, and so on. Now comes the classification of the risk. By analyzing the severity of harm and other factors, it's possible to classify the risk. Once the risk level has been rated, it can be reduced by introducing safety measures to make the machine safe and compliant. Now let us recap step by step in more detail. What are the so-called limits of a machine? There are 4 different types of limits. Probably the most important are the use limits, which describe the intended use of the machine, but also must consider foreseeable misuse. These must take into account different operating modes, areas of application, and expected knowledge of the users. The so-called space limits, on the other hand, describe the physical demarcations of the machine, such as where are the interfaces between man and machine and which power supply is required. They relate to the space required for people to operate, clean or maintain the machine. Time limits then tend to be more relevant for the life cycle of wear parts that are required for safe operation. Then we have other limits which look at such things as where the machine is used, whether it is in enclosed spaces or outside, exposed to wind and weather. On to the next step, to identify the source of dangers. For this we need to know what kinds of hazards they are. To help with this, the standard provides a 3 pages long list of hazards in groups. Take a look at them. You will be amazed by the range of things that can cause danger. It is especially important to consider the different life stages on the machine. To make a machine safe in normal operation is difficult enough. Planning for special protective measures during maintenance and cleaning creates even bigger headaches. Many accidents actually do occur during maintenance and repair, so I would like to again point out that very special attention should be given to these aspects. Let us come to the estimation of the risk. Unfortunately, there is no specific rating system provided by the standard. It would be so simple if there was. In fact, a variety of different systems exist. Some easy, some hard, and some complicated and hard to understand. A very common, plausible and internationally known procedure is the Hazard Rating Number System, or HRN for short. Using the Hazard Rating Number System, the risk is classified by factors including the severity of harm that could be caused, the number of people that could be affected, how frequently the risk occurs, and how likely it is that an accident will happen. All the individual criteria have a special weighting and are ultimately multiplied by each other, leading to a risk between 13,500 and 0. The higher the number, the higher the risk. Typically, the initial hazard rating will be a high number which must be reduced. Usually, the easiest factor to reduce is the likelihood of an accident happening, because the other factors are often dictated by the nature of the process. This reduction is achieved by the introduction of safety measures. In this way, the hazard rating will be reduced, often by a number of safety measures, until the remaining risk is low enough to be acceptable. To minimize the risk of such a machine, there are of course numerous possibilities. It is important to take into account the so-called three-step method. Some hazards can be eliminated at the first step of the process during the design and construction of the machine. In the second step, it's possible to select safeguarding and/or complementary protective measures to add to the machine. These can include fixed or movable guards or electrosensitive protective systems, such as light curtains. As a last resort, to further reduce risks, you can select things like personal protective equipment, pictograms, or safety instructions in the user manual. Now you have an overview of what ISO 12100 defines. Applying this standard to your work, however, is not so simple to do. That's why we have created our software, so-called Safety. It allows you to embed compliance into your design process and provides evidence of that compliance. For more details on how to apply this process, look out for the next video in this series. That's it for today. Thank you for watching.